Hello Algebra, welcome to Monday. So today we're going to be talking about solving equations with square roots. You all love solving equations, so we're just going to add a little bit of a twist to it, but our inverse operations and everything we know about solving equations is going to apply here. Start out with some complex solving equations questions. Do these 2 questions and then come back and review with me to see if you got the correct answer. All right, let's take a look. So I can see here that I've got to do some distributing before I go ahead and do my inverse operations. So I'm going to multiply this 2 times the 6, which gives me 12d, 2 times negative 15, which gives me negative 30, and that will equal negative 12d plus 6. On this side, I distributed the 3. It kind of looks backwards, but it doesn't matter. It's still distribution property. Now that I have an equation here, I could use my inverse operations by solving and combining like terms. If you see here the 12 has a d and this negative 12 has a d, I'm going to move this guy over to the left. Why? Variables to my left, numbers to my right. Inverse operations, I would add 12d. 12d plus 12d gives me 24d. So this becomes 24d minus 30 equals 6. Okay, so then when I'm solving here, I've got my variables to my left, numbers to my right. So that means I'm going to be moving this 30 to my right. 24d equals 36. So now I'm going to do my last step. Get rid of this 24. There's multiplication. Opposite of multiplication is division. 24 doesn't go into 36. So essentially here I've got a fraction. It's okay to leave it like this. Let me think about what would be the most simplified form here. Do they both go into 12? I believe so. So you could say also or d equals 3 over 2. And then you would be good. Okay. Now the second question was number 2. We have 18 plus 5 times 2c plus 5 equals 12. Again, you're going to have to do some distributing here. So 5 times 2 gives me 10. 5 times 5 gives me 25. And drop everything else down. Okay, combine like terms. I have a community property I can apply here. You see how the 18 and the 25 are like terms? So I'm just going to do some switching around commutative property to bring those both together. Then what you want to do is add 18 and 25 since they're like terms. 10c plus 18 plus 25 is 43 equals 12. Now, variables to my left, numbers to my right, my c, my 10c is already in a good place. What I need to move is the 43. The inverse of plus 43 would be minus 43. So 12 minus 43 is going to be a negative number because the 43 is higher, so it holds the power. You want to find the difference between 12 and 43, which should have gotten you negative 31. Again, I'm going to have a fraction here because when I divide by 10, I would get a decimal. So it's fine just to leave it as negative 31 over 10, or if you put negative 3.1, that is fine too. All right, so back to our lesson here on solving for quadratic equations with square roots. Make sure you have this in your table of contents, and let's move forward. So the first thing that we need to talk about is simplifying radicals. We kind of did this when we were learning about exponents, but we're going to review it here again. You may have seen it before in previous math classes as well. Example number 1, you see how it says a plus minus there? I want to talk about that before I do those examples. Write this down in your notes. When solving for the square root, you will always have 2 solutions, a positive and a negative. We say this as plus minus. So whenever you're finding the square root of something, so in this example here, I square rooted 25. Your two answers are a positive 5 and a negative 5. Why is that? Well, if you do 5 times 5, you get 25. But also, if you get negative 5 times negative 5, you get 25 as well. So both of these would be answers to this problem. It can be either a plus or a minus. So we indicate that with just a simple, that's plus minus. Make sure you pause and get this down if you are not finished. Back to our examples. So these signs in front of the radicals are plus minus. Also, if you remember, when I have a radical, there's an imaginary 2. So these are all square roots. If it was trying to find a different root, like the third root or the fifth root or the fourth root, then it would have that number. Since it doesn't have a number, I know I'm finding the square root, meaning two numbers that multiply to give me that number. So example number 1 here, we have the square root of 27 over 25. I know that the solution is going to be either plus or minus, so I write that plus minus in front of it. The square root of 27 doesn't exist, but the square root of 25 does. So I want to be more creative in trying to think of how I can simplify the square root of 27. Think about factors. We talked about factors a lot in the previous couple of weeks. What are the factors of 27? I know that it's 1 times 27. It doesn't go into 2. It does go into 3. And I believe that's it. Taking a look at these factors, are any of them perfect squares? Perfect squares are things that mean that two numbers can go into that number, and it has to be the same number. So for example, 9 is a perfect square because 3 times 3 gives me 9. So when I'm breaking apart this radical, I'm going to use this pair here. Another example of a perfect square is like 25, 100, 9, 25, what else? 81, anything that makes a perfect square. So the 25 I can simplify already. I'm going to break apart this radical into two radicals. So it's going to say the square root of 27 over the square root of 25. That way, when I am doing my simplification, I can say that this is going to be the square root of 9 times 3 over 5, because the square root of 25 is 5. Now I'm going to break apart the top radical even more. So instead of 9 times 3, I'm going to write the square root of 9 times the square root of 3, all over 5. Now take a look, I can actually simplify something here. The square root of 9 is a perfect square. That means I can square root it. That would be 3. So my final answer here is going to be 3 root 3 over 5. This is what I would type into my HMH, okay? So what I did here is I took the problem, square root of 27 over 25, and then tried to figure out how I can simplify this into perfect squares. 25 is already a perfect square, so I can simplify that as 5. 27 is not a perfect square, but its factors have perfect squares. So saying 9 times 3 is the same thing as saying 27. So instead of putting 27 in the radical, I put 9 times 3. Then I broke apart the radical so I could simplify each side. The square root of 9 times the square root of 3. The square root of 9 is 3, and then the square root of 3 is a decimal, so I'm not going to simplify that. I get 3 square root 3 over 5. Okay, let's take a look at example number 2. Example number 2 will be the square root of 8 over 25. So again, here I have the same type of situation. 8 does not have a perfect square, but its factors do. So if I'm thinking about factors of 8, I have 1 times 8, and I have 2 times 4. So this pair here has a perfect square, 4. So I'm going to rewrite it as 2 times 4. Then if you look at the bottom, it's 25 again. We know that the square root of 25 is 5, so that can just be written like that. plus minus, break it apart, square root of 8 over square root of 25. Simplify, the square root of 8 is going to be written as the square root of 2 times 4 all over 5. Now take a look at this radical here, plus minus the square root of 2 times the square root of 4 all over 5. This can be simplified as 2. I'm going to bring it to the front because it looks more natural that way. So if I write something like plus minus square root 2 times 2 over 5, that's not as natural. Your HMH may take it as an answer, but the best thing to do here would be to rewrite it with that 2 in front. So even though the square root of 4 I put in back, it doesn't matter, it means the same thing. Put it in front, it looks a lot cleaner, okay? So my final answer would be 2 root 2 over 5. Remember, it's a positive or a negative, okay? So let's take a look again here. We had the square root of 8 over the square root of 25. Square root of 8 does not have a perfect square, so I've got to break it apart and look at its factors. I chose 2 times 4 because 4 is a perfect square. The square root of 25 is 5, so I could simplify that. Then I broke apart the radical into the square root of 2 times the square root of 4. Therefore, I could simplify the square root of 4 to make 2, and now I have my simplified square root situation, 2 square root 2 times 5. Okay, I'm going to write example number 3 here for you. You have the square root of 125 over 81. So see if you can pause the video and see if you can simplify the square root of 125 over 81. Try thinking about the factors of 125 and if maybe 81 is a square root, has a square root. All right, let's check your work here. So 125, you should have gotten factors like 1 times 125. You have 5 times 25, and I believe that is it. Okay, and look at that, you've got a perfect square, so this is going to work for us. I'm going to choose this pair here. The square root of 81, hopefully you figured out, was 9. So when I rewrite my problem, I have the plus minus the square root of 125 over the square root of 81. I'm going to rewrite my 125 as the square root of 25 times 5 all over 9. Break apart your radical so you have plus minus, I don't know what this is, plus minus, and I have the square root of 25 times the square root of 5 all over 9. The square root of 25 is 9, so this will be the square root, whoopsies. This would be 5 times the square root of 5 times 9. Okay? This would be your answer that you plug in to HMH. All right, let's move onward with it. We'll come back to that idea if you've forgotten. Hopefully it's just a review from what you've previously learned. Now we get into something that I think this is actually easier. This is supposed to be easier, but this is easier. X squared minus 4 equals 0. So what we're doing here is basically solving an equation. The same thing's going to apply, that I want my variables on my left and my numbers on my right. So you can see here they move to the 4 to the other side by doing inverse operations, which gives me x squared equals 4. Then you want to think about, you have x squared, not just x. So usually in this step you would divide, but now what we're going to do is square root. So I rewrite the square root of radical over x squared because that undoes a square, okay? We can talk about that if you would like to. Otherwise, just know that the opposite of a square is a square root. If I square root both sides, don't forget your plus minus situation. And then if I square root 4, it does have a perfect square, 2. Don't forget the plus minus because it can be either 2 or negative 2. The solution is positive or negative 2. Okay? So here I'm going to go over again. When I take a square root, there's 2 solutions, a positive and a negative. We indicate that with a plus minus sign. Okay, example number 1 here, I'll just talk through and you can write this down as you wish. You have 2x squared minus 2 equals 16. The first thing I need to do is get rid of the minus 2, numbers to my right. So I'm going to bring it to the 16. In order to do that, since it's minus 2, I added 2 to both sides. Then you get 2x squared equals 18. Now, the next step here is to divide by 2. Why do I divide by 2? When you have a coefficient in front of x, you need to get rid of it. The operation is multiplication, so the opposite is division. 2 divided by 2 cancels it, you're left with x squared. 18 divided by 2 is 9, so you're left with 9. Then I have x squared. Remember in the previous example, I told you that the opposite of a square is a square root. So I'm square rooting both sides. The square root of 9 is x equals 3, or what do you think? Hopefully you said negative 3. So we write this as plus minus 3. Okay. Example number 2, write it down. 22 minus 3x squared equals negative 53. So I have 22 minus 3x squared equals negative 53. Think about all of the things that you've learned in solving equations. Numbers to your left, variables to your left, numbers to your right. My variable is already on my left. What I need to get rid of is this 22. How do I get rid of it? Well, it's a positive, so in order to get rid of it, I need to subtract it. Minus 22 minus 22. Drop down your negative 3x squared. That gives me a negative, same signs, I can add 75. So 53 and 22 make 75. Keep the sign, same signs, add and keep. Then I have a coefficient in front. So how do you get rid of the coefficient? You divide. Don't forget to divide by a negative because that negative 3 is there. Negative divided by negative, I know is going to be a positive. 75 divided by 3, hopefully you know, is 25. So now I have x squared equals 25. I divided here, simplified to get 25. Now what's the opposite of an x squared? Hopefully you're saying square root. So what I'm going to do here is square root both sides. When I square root, remember these solutions are plus, minus. What's the square root of 25? Hopefully you know is 5. So my solutions are 5 or negative 5. We should write and. 5 and negative 5. Okay? All right, so that's example number 2. Let's go ahead and do example number 3. Example number 3, I'm going to give you a fraction because you have a fraction in your HMH. Remember, if you need help on HMH, you can always do the step by step and then try another. It'll be the exact same problem but different numbers. So in example number 3, we have 2 over 3 times x minus 40 squared equals 6. When you're getting rid of the fraction, remember you can clear the fraction by multiplying by the denominator. The denominator is 3. So in order to clean this up, I'm going to multiply both sides by 3. That essentially cancels, and you're left with 2x minus 40 squared equals 18. Then what I can do is get rid of this 2, since normally we'd want to go ahead and distribute here, right? But that's just going to make you a big mess. Get rid of it by dividing. The opposite of multiplying is dividing. When I'm distributing, I'm multiplying. The opposite of multiplying is to divide. Okay? So let's get rid of that. And I'm still with the x minus 40 equals 18 divided by 2 is 9. This is looking good for me. So now that I have x minus 40 squared equals 9, you may be thinking, oh, move the 40 to the other side, right? No, don't do that because the x minus 40 is in parentheses. So everything is squared. What is the opposite of a square? The opposite of squared is square root. So what I'm going to do here is square root both sides. When I do that, I'm left with my x minus 40, you don't need it in parentheses anymore, equals plus minus 3. Okay? Now what I need to do is move the 40. When I move the 40, I have two options. It's either 3 or negative 3, right? That's what the plus minus sign stands for. So I have to do two problems, kind of like when we're solving for our inequalities. The first one is going to be x minus 40 equals 3, and the second one's going to be x minus 40 equals negative 3, all right? When I do that, I'm going to add my 40, add 40, x equals 43, add 40, add 40. This time, x equals 37. So those would be my two answers in this case. A little more steps when there's a fraction. Clear it by multiplying by the denominator, then divide the coefficient in front, then square root, then set up two problems in order to figure out what your solution is because of that plus minus symbol. So that takes care of solving equations with square roots. Make sure you go ahead and do your HMH and reach out if you have any questions.